Good morning, students. Students, for the past few days, I have been sending you videos from FlipLearn to go through the portions on mixtures. Mixtures, students, if you have gone through the videos carefully, and if you haven't, you must go through them. They are of two types, homogeneous and heterogeneous mixtures. And when I talk of homogeneous, I mean uniform mixtures when the components are mixed uniformly, and heterogeneous means non-uniform mixtures. One of the example of homogeneous mixtures that you have studied is solution. And a solution is a homogeneous mixture of a solute and a solvent. This also you have studied. You have studied the properties of a solution in the previous video, wherein I had sent you a worksheet also, and some of you have sent me the worksheet back and some of you haven't. Please do it on the allotted days. Alright, so in this session today I am going to talk about article 2.2.1 in your NCERT, that is concentration of the solution. Concentration of a solution means we are going to talk about the relative proportion of a solute and a solvent. We know that a solution is made up of a solute and a solvent. Solute is a substance that dissolves in a solvent. Now this proportion, the proportion in which a solute and a solvent are mixed, can be varied. You can have a larger amount of solute as compared to the solvent. You can have a larger amount of solvent as compared to the solute. Now depending upon the amount of solute that is present in a solution, the solutions are of broadly three types. That is dilute, concentrated, and a third type is a slightly different type, and we are going to study the variants later on. Now dilute and concentrated are the two terms that I am going to talk right now. Dilute and concentrated are relative terms. Relative terms means we talk about dilute and concentrated solutions with reference to each other. A dilute solution is a solution in which the amount of solute is less as compared to the solvent. So it has lesser amount of solute, more amount of solvent, and when the amount of solute is much less as compared to the solvent, it is known as the dilute solution. Suppose in 1 liter of water you have added 1 teaspoon of sugar. Now sugar is the solute, 1 liter water is the solvent. The amount of water is much more as compared to 1 teaspoon of sugar. So the resultant solution, when you will stir and dissolve 1 teaspoon of sugar in 1 liter of water, it would be a dilute solution. Now I talk of the concentrated solutions. What are concentrated solutions? Concentrated solutions as compared to the dilute solutions are those solutions. Please remember, I am saying concentrated solutions as compared to the dilute solution. Why am I making this statement? Because I have already explained that dilute and concentrated are relative terms. So concentrated solutions are those solutions that have high amount of solute as compared to the dilute solutions. So here, if I have taken the example of 1 teaspoon of sugar in 1 liter water, if I talk of the concentrated solution, then I can say I have added 400 grams of sugar in 1 liter of water. So here the amount of sugar is much more as compared to the 1 teaspoon of sugar that I added to prepare a dilute solution, and that is why this solution, where I have dissolved 400 grams of sugar in 1 liter of water, it would be a concentrated solution. Now this solution, saturated solution, is a term that I am going to explain you, again taking the example of sugar and water. I hope you've seen your mother preparing sugar syrup at home when she's preparing some sweets or some dessert at home. So what she does, she adds sugar if she needs to make the shira or the chashni, which we call. Alright, she adds a lot of sugar and keeps stirring it with the help of the spoon. Some of the sugar dissolves, while when she's added a large amount of sugar, then it stops dissolving and starts settling at the bottom of the beaker. Then what your mother does, she just puts the beaker on the flame and then again starts stirring it, and the rest of the sugar dissolves. So when your mom is adding sugar to water and she's not at that particular temperature, at the room temperature, when she's not put the vessel on the stove. So I'm talking about saturated solution at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving. Means it can, the maximum amount of solute that it can dissolve at that particular temperature without heating. At that particular temperature, without heating, it is said to be a saturated solution. Now, from this stems the term solubility. Solubility is the amount of solute present in a saturated solution. How much amount of solute is present in a saturated solution at that particular temperature is called the solubility. It is basically the maximum amount of solute which is dissolved in 100 grams of a solvent at a particular temperature. Now I state the factors that affect the solubility of a solute in a solvent, and those factors are temperature, pressure and particle size. Temperature. I told you that as the sugar stops dissolving, what your mother does, she puts the vessel on the gas, turns on the gas, and the sugar starts dissolving. So sugar is a solid. The solubility of the sugar increased with increase in temperature. So the solubility of the solids, this up arrow increases with again up arrow increase in temperature. However, the solubility of the gases, down arrow, decreases with increase in temperature. For example, we know that water has dissolved gases, right? And in these dissolved gases, like dissolved oxygen, aquatic animals breathe. Now if you take water in a pan and you start heating it, what do you see? Small bubbles coming out and then larger bubbles coming out. What are these bubbles? From where are they arising? These bubbles are basically nothing but the dissolved gases in water, which are now escaping because you are increasing the temperature of water, which means they were dissolved at a normal temperature, but when you started increasing the temperature, the solubility of the gases in water decreased and it started escaping from the water. Now, pressure. Solubility of the solids and liquids is not affected by temperature, but the solubility of the gases increases with increase in temperature. Like when the cold drink bottles are packed, they are packed under pressure. When you open them, then you see a lot of fizz and bubbles coming out. What are these fizz and bubbles? These fizz and bubbles are nothing but the dissolved carbon dioxide that was made soluble in the cold drink when the pressure was applied during their packaging. But once you open the cold drink bottle, you are releasing the pressure, that is, you are decreasing the pressure and the solubility decreases. So the solubility of the gases is directly proportional to temperature, means when you increase the pressure, the solubility of the gases increase. When you decrease the pressure, the solubility of the gases will decrease. Next is the particle size. For all the types of the solute, smaller the particle size, whether I am talking about a solid or a gas or a liquid particle, the smaller the particle size, the greater will be the solubility. Now, next which I am going to talk about is the concentration of the solution and the various ways or methods of expressing the concentration. Today I will just be briefing you about the different formulae, and in the next video we will be using the formulae to solve certain numericals. What is a concentration of solution? It is defined as the amount of solute that is present in a given amount of the solution. The given amount means mass or volume of a solution, or it can also be said as the amount of solute dissolved in a given mass or volume of a solvent. So the rest of the definition remains same. The last term, here it is solution and here it is solvent. You can use it for either. Now I told you there are different methods or ways of expressing the concentration of the solution. The first way is mass by mass. Mass divided by mass percentage of a solution. And it is expressed as mass of the solute upon the mass of the solution, and because it is a percentage, that is why we multiply it by 100. And the next is mass by volume. Here it was mass by mass. Here we divide mass by volume. That is mass of the solute divided by the volume of the solution into 100. Now students, please go through the video very carefully, view it, review it, compile the notes, and in the next video I will be doing numerical problems on these two formulae and then moving ahead with the chapter. In case of any doubts, please feel free to send me your query. Thank you.